Okay, so a classic thing we do with all functions and all equations is, is to actually solve equations. So let's take a look at how we solve exponential equations. As you look at this handout here, you'll notice that everything is, our base is 2, our base is 3, etc., etc. So we truly have exponential equations. It turns out that solving exponential equations, most of them require its inverse, which I already shared with you as a logarithm. But right now we're going to kind of keep it simple, because you'll notice what's happening in these things, especially the first two, is that the bases are the same. So if my bases are essentially the same, then what that implies is that those two powers have to be the same. That's the only way that equality continues to happen. So we're basically going to take the time to first make sure we get the bases the same, and then as soon as I get the bases the same, I just simply put the powers together. So in this case, if I subtract 3x from both sides and subtract 1, we get negative 2x equals negative 2. If we divide by negative 2, we get x equals to 1. And really easy to check, because 1 plus 1 is 2. So we get 2 squared on this side. 3 times 1 is 3. Take away 1 is 2. We get 2 squared on that side. Right? So there, right, tells us that what we did is true. It makes the equation true. Same thing for this next one. My bases are already the same. So that means that the power on this side has to equal the power that's on that side. So it's that, dare I say, simple. All right? And so now what we have to do is solve that equation. It's a quadratic. So the classic way that we solve a quadratic is to move things over, and hopefully it factors. And in this case, I think we get x minus 4 and x plus 2, right? So x minus 4 equals 0, x plus 2 equals 0, and we get 4 as a solution, and we get negative 2 as a solution. So I'll let you guys check the 4. Here's negative 2. So if I put negative 2 in here, we get 3 to the 4th. If I put negative 2 in here, we get 2 times negative 2 plus 8. We also get 3 to the 4th. So 3 to the 4th equals 3 to the 4th. We did a good job, right? We did things correctly, okay? And so that pattern is just going to keep existing over and over and over again. So the next one, we have a little bit of a problem, because one side we have base 4, and right now this is 64 to the first power, and so at this moment in time we're going to go, whoa, I can't solve it, right? But what we can do is change it to something like this up here. So we already have 4 to the 2x power here, and if we think about it, 64 is 4 to the 3rd. And there we go, we got it, right? My bases are the same, so that must mean my powers have to be the same. So solving for x, we'll divide by 2, and lo and behold, we get 3/2 as our solution. And so the next one looks a little intimidating. Not only do we not have the same base, but we have a fraction, but have no fear, right? What do we know about 1 over 25? Well, that's 5 to the negative 2. So that means that's equal to 5 to the x plus 4. And so since my bases are the same, that means my powers have to be the same. So subtract 4 from both sides. The solution to this guy is x equals to negative 6. I'm going to do this one last in another video, but this one, again, don't let the fact that e, right, that's just a power, and right over here, or excuse me, a base. So since my base is the same, right, I can take the power here that's 1 and set it equal to the power there that's 2x plus 5. So base e, it's still, we estimated at about 2.718. So it's a number, and just like we did with the 2s, the 3s, the 4s, and the 5s, right, I'll just treat it as the same base and put my exponents together. So solving this, we'll subtract 5. We get negative 4 equals 2x. Dividing by 2, it looks like x to the negative 2 satisfies that particular equation, and I'll let you guys switch that up. So we're about 5 minutes into this, and this one, let's just kind of talk about it, and then I'm going to cut to a new video to fully do it. But this one's quite complicated because we've got a bunch of things going on and nothing's of the same base. So the challenge here, right, is we need to get this into the same base. If we can get it to the same base, left and right, then we can use what we've been using all in the other aspects. But let's go ahead and cut away, since there's a lot of crazy things going on there. Really, it just comes down to remembering your exponents. It's not too bad, your exponential rules. But I'll cut away to a new video, and we'll do it nice, fresh, and clean. See you guys in a moment.